Okay, we're recording. So we talked a little bit about the CyberKey stuff. So if anyone has any questions, hit me up in Discord or shoot me an email if you have any questions. All right, so we talked about sections 1 and 2, and then we're going to do 3 and 4. And then on Friday, we'll do module 7. Okay, so today we're doing examine cache, cookie, and history recorded in web browsers. And then after that, Windows files and metadata. All right, cache, cookie, and history analysis. This is really fascinating. You can find a lot of stuff in here. So examining web browsers like Edge, Chrome, Mozilla, Firefox, and there's just a whole ton of them now. Provide crucial evidentiary data like web history, cookies, and cache information pertaining to users' browsing activity. So here's some examples. Google Chrome, cache, cookies, and history, and it shows you where these are located. And I will say, knowing where they are is not something that you have to memorize. It will come naturally. Like, I will say that after a while, I got really good at finding because Google's, one of the most frequently used. I got really good at finding that one. But if you end up running into a more obscure browser, you can always go out and search for, just type in, where is the file path for, and then the name of it. And it'll give you how to find the history and cookies and cache locations. As you see, there's a nice little graphic over here on the side where it's marked out in red. Okay, analysis tool, Chrome Cache View. This is a small utility that reads your cache folder of Google Chrome and displays a list of all files currently stored in your cache. And you can see right here, it'll tell you what type of content type it is, how big the file size is. One of the things that I cannot stress how important this is, the last accessed can be a really big key indicator, especially when you're building your timelines. And also to figure out, okay, did this person access this? Okay, it should have been this person. Maybe someone else got in and accessed it because we don't have any proof that they were actually logged in at this time. So those can be really good for that. It displays, like it says here, it has your file name, your URL, expiration time, server names, and server responses. So there's a lot of stuff you can get just from that one little tool. This is the Chrome cookies view on here. And you can see here, it's got a nice little list out there too. Displays the list of all cookies stored by Google Chrome, and it allows them to export it into an XML file, which is really nice, especially if you're going to be including it in a report. Displays things like host name, path name, value secured, is it yes or no on that one, HTTP only cookies, yes, no, last access time, creation time, and expiration time for each cookie. This is the history view. And this is basically the same thing, just with history data files. And it shows the list of all visited web pages in the last days. And then you have your URL title, visit date and time, how many times it was visited, number of times the user typed the address in, the refer, and visit ID for each visited web page. Cache, cookie, and history analysis for Mozilla Firefox. So as you can see, they're all in different locations. Usually when you're looking for these, they're under the user and then app data and whatever section for that program. At least that's been my experience. There's a couple of analysis tools. There's MZ Cache Viewer, Cookie View, and History View. And there's some, you can see some nice links down there for that. Microsoft Edge. And again, you see here, this one's under users, but instead of, it's under admin and then app data. But it's like I said, you're going to look for it under users and app data somewhere. And then there's IE cache, edge cookies, and then browsing history, and there's the download area for those. Okay. So next, we have examination of Windows files and metadata. Yeah, no, I'm not a huge fan of Edge, but it's unfortunately, since it is installed as default on most systems, you're going to see that a lot if you've got a Windows system. One thing that you should also know is there are some things like Tor browser which work completely different. So just be aware that not every browser is the same, and there are some high security browsers out there that are a lot more difficult to track where things are saved, or if they're saved on your computer at all. Okay. So Windows file analysis, forensic examination of restore point log files and prefetch files provide information like MAC timestamps, file names, file sizes, number of times the application has been run, the process name, and etc., related to the installed and uninstalled information. So why do you think that, and this is something that you've seen a couple of times, why do you think it's important to figure out how many times an application has been run or a place has been visited in an investigation? Why do you think that might be something that could be used? Yeah, it could be motive, depending on what you're researching. It could also point
to, could it point to a pattern or pattern of behaviors, or I can't think of what it would be.
You can use them.
There was
to profile
wasn't there
the person.
What was that case where the husband like murdered his wife and they used his search history against him, where he was like, how long a body takes to decay, is it easier to cut it?
Several, yeah. It's surprising how many people they go back and find things like that, or they find all sorts of things where they will have IM history talking about, I wish my wife would die, ha ha ha, JK. But once is a joke, 50 times is a pattern, a serious pattern. So when you do things with file analysis, it's very similar to when you do profiles of human behavior. So you're looking for patterns, just like you would look for patterns of human behavior. If you're looking for, let's say, for example, it's kind of icky, but it's one of the things that computers are used for a lot. In the kiddie porn cases, if someone accidentally stumbles across the site and immediately runs away from it, and you never see anything else like that in their browser search history ever again, then it's pretty clear that that was an oops, holy crap, I'm not supposed to be here. However,
probably a fair thing to say is if you stumble across something like that, you might just want to report it.
Yeah, and that is another thing. Sometimes you can accidentally stumble across stuff like that and go, oh my gosh, I didn't know this was here. Well, the FBI has websites out there where you can report those. And sometimes people have such a violent reaction to it that they will just, it's almost like rage quitting. They just want to throw the computer across the room. So they're like, so sometimes they don't get the full address. Excuse me. So sometimes you'll get a piece of it, or, they just have, like, I went to this place and ended up here. And they can turn that over to the FBI, or they can turn it over to their local police. But if you're doing an investigation and let's say you're doing an investigation about something not related to kiddie porn charges, and you see like one weird spike like that, you can go, okay, this is probably an anomaly. I'll note it, because it's always good to keep records of everything, whether you think it's important or not. And then go on with your stuff. And if you don't see anything else, there's a good chance that they'll just go, okay, this was an anomaly. This is not relevant to the overall pattern of the case. Whereas if you're working on something that is not thought to be tied to a kiddie porn case, and you come across 50, 60 hits to various servers and all sorts of stuff like that, it's pretty clear that you have an underlying problem or a connection to a kiddie porn case, which has happened numerous times in different forensic files and things that I've seen, where you have intersections between different crimes, and they're like, hey, I know we're investigating this, but hey, look what we found. And then they have to get a warrant to go searching for more. So in that's your that's why they really pay attention to the number of times that applications are being run or places are being visited, because it can really indicate that pattern that might need to be run down. So yeah, good job. System restore points, or RP log files. These are the restore point log file located within the restore point, or RPXX directory. It includes value indicating the type of the restore point, a descriptive name for the restore point, creation event, and the 64-bit file time object indicating when the restore point was created. System restore points are created when applications and unsigned drivers are installed, and when an auto update installation is done, and you have like the auto update and restore and thing that pops up, and when that happens, when that operation happens, then it creates one of those points as well. Description of the event that caused the restore point creation is written into that RP log file, and the log file helps the investigator to notice the date when the application was installed or removed. So one thing to keep in mind about this is a lot of times illegal programs cause problems with Windows because they have unsigned certifications, bad DLL files, all sorts of issues. So you'll get these kinds of error messages and things that will kick on these restore points. And you can find indications of them through this RP log file. Then there's the change log file. File changes are recorded in the change log files, which are located in the restore point directories. Changes to the monitor files are detected by the restore point file system driver. Original file name is entered into the change log file, along with the sequence number and the type of change that occurred and some other information. The monitored file is preserved and copied to the restore point directory and renamed, and you see that rename format, where X represents the sequence of numbers and EXT is the file's original extension. First changelog file is appended with a sequence number, and a new changelog file is created when the system is restarted. So this is a good place to look so that you can see your pattern of issues as well. Prefetch files. When a user installs an application, runs it, and deletes it, traces of the application can be found in the prefetch directory. D-word value at the offset of 144 within the file corresponds to the number of times the application is launched. D-word value in the offset 120 within the file corresponds to the last time the application was run, and the value is stored in UTC format. Information from the PF file can be correlated with the registry or event log information to determine who was logged on to the system and who was running which applications. So this is your, let's say they have an application that they don't really want people to know that they ran. They run it, they delete it. They think, okay, you're not going to be able to find it. This is how you find indicators of those types of programs. So it's used by the OS to Windows OS to speed up system boot process and application launches. The data is recorded for the first 10 seconds after the application process is started. Once the data is processed, it's written to that PF file in the Windows prefetch directory, and the forensic investigator should identify whether the victim system has enabled the prefetching process before conducting the examination. So if prefetching is enabled, you can get a lot of information off of this. And there is the registry key that controls prefetching, and the data associated with the value of enabled prefetcher tells which form of prefetching the system uses. So if it's 0, it's disabled. 1, application is prefetching is enabled. 2, boot prefetching is enabled. And 3, they're both enabled, application and boot prefetching.
Quick question on the prefetch files. Would
Yes.
these also be a thing for cell phones?
You know, I'm not sure, but I do believe, I'm not sure where they would be, but I do believe that they have a form of prefetch on most cell phones, just because it really does speed up how things boot.
Well, I was just thinking along the lines of, especially with cell phones nowadays, there'd be a lot more of downloading and immediately getting rid of things for apps and such.
Yeah, that is a very good point. Yeah, mobile forensics is its own beast, but I know that they have something that is similar. I'm not sure if it's called the exact same thing. Image files. So metadata present in JPEG image file depends largely on the application that created or modified it. For things like digital cameras, embedded exchange image file, so EXIF, information and images, which can include model and manufacturer of the camera, and they even store thumbnails or audio information. There are all sorts of little things in your video and image files that you can find when it comes to metadata, which is why they are so cool in order to find stuff like this. So there are tools like EXIF2 or FondView and image metadata, that one with all the columns, JPEG, which is a Perl module to view, retrieve, and in some cases you can modify the metadata embedded in JPEG image files. Tools like EXIF Reader, EXIF Library, and EXIF Tool Display EXIF data found in JPEG images. Now they have them for pretty much all versions that you can imagine of image files. And I will say that because you can change metadata, there are also forensic tools to detect changes to metadata. In computer forensics, metadata is obtained from databases, image files, Word files, web browsers, etc., and contains evidentiary data of forensic value. It usually contains a lot of data. File names, file sizes, MAC timestamps, GPS data, etc., can be in your metadata. Understanding metadata. Metadata is data about data. Literally, that's what it is. It describes various characteristics of data, including when and by whom it was created, accessed, or modified. Because it is not normally seen, users can inadvertently share confidential information when sending or providing files in electronic forms. So here are some examples of metadata: organization names, author names, computer names, network names, hidden text or cells, document versions, template information, personalized views, non-visible portions of embedded OLE objects. The investigator can use tools like Metadata Assistant, Paraben P2 Commander, and MetaShare Analyzer to analyze the metadata. Yes, that is an excellent point. So this is also why when I teach classes to, it's funny because I like to think of them as civilians. When I teach classes to civilians or people who do not know anything about cybersecurity, I have a huge section in my social engineering where I talk about metadata and scrubbing your metadata from your pictures. Because a lot of people don't realize that almost all of your pictures, unless you disable it, have your GPS data right there in it. And there's a lot of other things in them that you need to turn off. And, you know, since we've become such a social media conscience, especially the younger the users, oversharing is very problematic. And it's just, you know, it can be a stalker's dream using that metadata. So teaching people how to manage their own metadata. Yeah, exactly. And this is also why when I tell people, if you're going on a vacation, don't tell the whole world before you leave. If you take a bunch of pictures while you're on vacation, great. Don't post them until you get back. Because posting them while you're out and about, you just gave them the location of where you're at. Because you might have disabled your GPS, but if you're taking a picture of the Leaning Tower of Pisa and posting it, you know, you just sent them a picture of a landmark, you know. So
Best way to do it is just not post anything until you get back.
that's exactly what I tell them. Yeah. If you're going to take vacation photos, that's fine, but do not post any of them until you come back. And sometimes that can be really difficult for people, but I just repeat that over and over again. Don't tell people that you're leaving. Don't tell people while you're on vacation. Don't post photos while you're on vacation. Post them after the fact. And then you can share that experience after the fact. It's much safer. Okay. After that side note, metadata in different file systems. The most commonly known metadata about files on Windows systems are your MAC times, and that's your modified, accessed, and created is what they're talking about. The MAC times are time-stamped that refer to the time at which the file was last modified, last accessed, and when it was originally created. MAC times are managed by the OS depending on the file system used. On the FAT file system, times are stored based on local time of the computer system. NTFS file systems store MAC times in Coordinated Universal Time or UTC format. Investigate the way the timestamps are displayed based on various move and copy actions. So how timestamps are displayed and changed in FAT16 and NTFS file systems shown below. So FAT16 is on the left, NTFS on the right. So you copy my file txt from C to C subdirectory on the same file, And my file txt retains the same modification date, but the creation date is updated to the current date and time. Then you move that from okay, so basically you just move the file and then it retains the same modification and creation times and dates. If you copy from a partition, let's say FAT16 to an NTFS, it retains the same modification date, but the creation date is updated to the current date and time. Then if you move that file from a FAT16 to an NTFS partition, it retains the same modification and creation dates. Now, with its NTFS, if you copy it, it retains the same modification date, but the creation date is updated to the current date and time. If you move it, it retains the same modification and creation dates. PDF files or portable document format files also contain metadata, things like the name of the author, the date when the file was created, and the application used to create the PDF file. I will tell you, people are terrible about remembering where, how, and why they should update these. So frequently these are wrong, and you can get some really interesting information out of them. Often metadata can show the PDF file was created on a Mac, or the PDF was created by converting a Word document to a PDF format. You can use Perl scripts, PDF meta PL, and PDF dump PL to extract metadata from PDF files. Or if you have Adobe Acrobat, like the full version, you can go in and look at the properties in there, and it gives you, just flat gives you that information too. Word documents are compound documents based on object linking and embedding, or OLE technology, that defines their file structure. Word documents contain not only past revisions, but also list up to the last 10 authors to edit the file. You can use Perl scripts WMD PL and OLE dump PL to list the OLE streams embedded in a Word document. To view metadata in Word 2010, you go to File and the File tab, and then Info option, and click Check for Issues, Inspect Document, and you can see a bunch of information there. Select the content to view, and click the Inspection button, and it really gives you a bunch of stuff you can see. Meta-analysis tool. There's MetaShield Analyzer. This is an online service that allows investigators to analyze metadata contained in files. My guess is a lot of these are subscription-based, so be aware of that. Okay. So what did we go over in the whole module? Remember, we split this up. We talked about the collection of volatile and non-volatile information. So do you guys remember the difference between volatile and non-volatile? Just give
One's
me
really bad if you take away power.
Yes, there you go. That would be volatile. Non-volatile is your hard drive and things like that. Volatile is things like memory. Then we discussed Windows memory and registry, and then we talked about the cache cookie and histories, and then we talked about Windows files and metadata. So next module is our Linux and Mac forensics. Pardon me. So, I want cookies. Hey, you remembered your end tag. Good job, Jeff. Okay. So, like I told you, it's a short lecture portion today. Then tomorrow, no, not tomorrow, Friday, we will do Linux and Mac forensics, and then we will do our little Friday forensics tool to play with. And then that'll be it for the week. Yeah, I know. He's gonna have to go back and check all the iframes he left open. So I'm gonna go ahead and stop recording for the lecture here, and we'll talk about all the CyberQ fun and labs. Okay,